Hi guys, this is Robin Gailunas. Sorry for being a little late. We were having some technical difficulties with our Wi-Fi, which I think we fixed now. But if we happen to get cut off, if we have problems again, we will definitely reschedule this. But I'm hoping that we can make it through to the end. Okay, let's get started. Looks like there are a bunch of you guys here already. Great. If some of you were here from my webinar yesterday, we're going to sort of continue in the same thing that we've been talking about and expand a little bit on it. Just as a quick couple of things, if you do have a globe, now would be a good time to go get one. But if you don't have a globe, don't worry, I have mine here and I'll be showing you some things on it. You're gonna need pencil and you're gonna need paper too. And then just a quick, if you're new and you're just joining my webinar for the first time, thank you for joining me. And this is kind of how it works. You don't have to take notes if you don't want to. I'm not gonna make you turn in notes. If you want to ask a question, we are gonna do it in the Q&A function. You might see that there's a chat function and a function to raise your hand, but we're actually not going to use those in these webinars. So if there's something I say that you don't get, or you need some help, or you have a question, just click in the Q&A and then I'll be able to see your question. Okay, so before you all should have received the book for the one that we're doing today, which is called Earth 2, Earth and Its Neighbors. And you might see if you're looking through it that, and you were on my webinar yesterday, that it's very similar. So we're just gonna, the way it will work is that I will read when we read things, and I'll have some slideshows that I'm gonna show you. Thank you for saying I'm nice. Okay, good. So just as a little bit of a recap, we're going to do a little bit of a recap, and just a reminder for, I see Emmett and Rebecca, you guys typed in the chat. We're going to do everything in the Q&A section. And Rebecca, it's totally fine that you're late. I was late myself, so I understand sometimes that happens. Okay, so just as a little bit of a recap, is the planet that we live on is called Earth. It's made of dirt and rocks. It has land, water, and air. There's a couple of words that I want to tell you guys what they mean if you don't know what they mean already. The first one is rotate, which is to move around in a circle. So for instance, here I am. You'll only be able to see the bottom part of me, but here I am rotating, right? And then the other one is revolve. So when you guys can see my little thing here, right? Here's the sun, here's the earth. It's starting to revolve. It goes around like that. So those are just two words that we'll need to know. The other thing is day and night. So right now, where you are, most likely, if you're near me, it's daytime, which means the sun is shining on the part of the earth that you're on. And the other part where it's not shining over here in my model, that would be nighttime. And I see I have, hi, McKenna, and hi, Milo. Great, I'm glad you could join us. And Alyssa has a question, why do we have the sun? Well, we have the sun because we actually need the sun for the planet to be warm enough for us to live on. So if we didn't have a sun, we'd kind of be in trouble, but I'll leave that to you to research. Good, I hope that, hi, Sophia. I'm glad you could join us. Okay, so the first thing we are going to read is, I'm going to put it up on the screen. We're going to read something called years. So you should have the lesson book up there, and we're going to read, and then I'll tell you the next thing we're going to do. While Earth is rotating through day and night, it is also moving around the sun. It moves around the sun in a big circle. When we talk about Earth turning through the day and night, we say it's rotating. When we talk about Earth moving around the sun, we say it's revolving. Revolving means to be moving in a circle. Earth takes a long time to move all the way around the sun. We call the amount of time Earth takes to move all the way around the sun a year. Suppose your birthday happened when the Earth was here. Then part of the year later, the Earth would be here. When it was your birthday again, the Earth would have moved back here. You can see there, it's the birthday. Earth has made one trip around the sun and 1 year has gone by. Earth revolves and rotates at the same time. So Earth moves in two ways. It moves in a circle around the sun, or revolves. It also spins or rotates. Earth makes just one trip around the sun each year, but it makes a complete rotation every day. So you can see if you're looking at the book, the little red arrow is showing the rotation. In 1 year, the Earth makes one trip around the sun. During that year, Earth rotates 365 times. This means that in 1 year, there are 365 days. Okay, great. So now we've done that, and I can see we have some questions. Let me just pull that up, if you'll bear with me. Thank you. So many of you are saying hi to me. I really appreciate it. Oh, why is your model, is the moon half black? And I think that's just here, if you look at my model, if you can see my bigger thing, here's the sun, right? And so the sun would be shining here. So there would be part of the moon that the sun's not shining on. And so the way they're showing that is by having it black. We are on page, Sophia, I see your question, what page we're on. We are on page 34. Okay, great. So now the next thing we're gonna do is I'm gonna show you one of the things that we went over. So if everybody can see my model, I'm gonna show moving 1 day. So here you can see it's rotating, and that would be 1 day. And then here, this would be the second day. And now I'm gonna show a year. As best I can, I hope you guys can see that. So that would be 1 year. And then if we wanted to show another year, that would be 2 years. Okay, great. So the next thing that we're gonna do is we're gonna read about the moon. Just 1 second. Great, Mitchell, I'm glad you're liking how easy this is to understand. And Brittany, your question, so the Earth actually rotates 365 times, because that's 365 days, as it revolves around the sun. So it goes around the sun once for a year, but within that year, every day of that year, it rotates. Hope that helps. Okay, so now we're gonna read about the moon. So we are going to move to page 36, I think. There we go, and we got a picture of the moon there. Going down, hold on 1 second. There's a picture of the Earth and the moon. The moon is a large round object that goes around our planet. When we look in the sky at night, we can sometimes see it. Once in a while, we can see the moon during the day, but it is not as bright as it is at night. The moon revolves around Earth while Earth is revolving around the sun. What the moon is like. The moon is made of rock and dirt. It does not have water or air on it. It is all land. There are many mountains on the moon. There are also round dents on the moon called craters. When you look at the moon through binoculars, you can see the craters and mountains. So there's a drawing of the moon. You can see a picture of a spaceship going to the moon. A few people have visited the moon. They made the long trip in a spaceship. It took them 3 days to get there. The people who traveled to the moon were called astronauts. When they reached the moon, they were able to walk around wearing special suits. The suits protected them from the heat and cold and gave them air to breathe. There's a picture of our astronaut. There's a little moon landing craft. The astronauts who went to the moon took pictures and did experiments so they could learn more about the moon. They even brought back some moon rocks. This picture shows the very first spacecraft on the moon and one of the first 2 astronauts who walked there. Great, and I think that is all we're going to read for that right there. Okay, Rebecca, I see you don't have the book. I will make sure you'll get, your parents will get a follow-up email once we're done with the webinar, and then maybe a little bit later, like maybe tomorrow, and I think I'll make sure they send you a book. Milo, I'm actually not sure how the moon was formed, but that would be a really good science research project. Maybe you could do that once we're done with the webinar. Okay, great. So now we're going to look, I have a slideshow that has some pictures of the sun, earth, and moon. Okay, Milo, I see you also don't have the book. So if there's anybody else who doesn't have the book, I will make sure that we follow up so that you get that. Wow, Evan, I don't know what would happen if you took a glass of water to the moon. But I think one of the things I do know is where there's sun on the moon, it's really, really hot. So maybe the water would be really, really hot. And places where there's no sun on the moon, it's really, really cold. So it's possible that it would freeze. But that's a really good question that I've actually never thought about. So thank you for asking. Okay, good. So I'm going to share my slideshow. So here is my slideshow about Earth 2 and its neighbors. So here's a picture of the Earth. You can see the land and the water, and at the top you can see a little bit of the clouds that are there. Next, this is a picture. This is one of my favorite pictures of the Earth. It's called the bubble, and you can kind of see if you look at it why they call it that. And it was taken by the crew of Apollo 17, which was part of the program that brought American astronauts to the moon. Here's some pictures of the moon. You can see the craters there, those holes. That's what we call the craters on the moon. And that's another, if you see the arrow, that's pointing to a very specific crater, but that's just another picture of the moon. Here's a picture of the sun. Looks really, really hot. And here, this actually was the closest picture that's ever been taken of the sun. When I was looking for pictures, that's what I learned about this one. And you can kind of see, if you can imagine the heat coming off of that. Okay, Sophia, I see you raised your hand. If you haven't already typed your question into the Q&A box, please do so. Rebecca, I actually don't know why every 4 years we have a leap year, so I'm sorry that I can't answer that question. And Brittany, you're right, the sun is so cool. And Alete, I hope I'm saying your name right, it definitely does look like it has hot peppers in it. It's probably as hot as if it had hot peppers. And Sophia, I'm glad that you didn't know that. I'm glad that this is being helpful. And I'm sorry, I don't know whoever it says anonymous. It definitely is. I don't know if it's fire on the sun per se, but there's something which is causing that heat. Okay, good, great. Well, we've looked at those pictures, so now we're going to move on to the next thing. I do see, Alina, you did raise your hand, so if you could type your question into the Q&A, that would be great. Hey, you're right, Amber, the sun is hot. And Emmett, I'm not sure actually if the sun can explode. I hope not, because we need it to live on Earth. But my technical person just assured me that it's not possible. How big is the sun? I'm not sure the actual dimensions or measurements of the sun. You guys are making me think a lot about these different questions. What makes the moon move around the Earth? Sawyer or Amanda, sorry. It's actually the gravity is what holds the moon close to the Earth. And Rebecca, yes, the sun is bigger than the Earth by a lot. It's just very far away. So in pictures, it doesn't look as big compared to the Earth. Okay, great. We're gonna move on to the next section. So we looked at some pictures of the moon, and we're gonna read something about distances in space. I actually think it will have a little bit about the size of the different things and how they compare to each other. So let me pull that up. Okay, good. You guys are asking a lot of really great questions. Let me read this little part and then I will try to answer them. Okay, so distances in space are huge. Just to compare, the distance across the United States from the Atlantic Ocean to the Pacific Ocean is almost 3,000 miles. It can take almost 7 days to drive across the United States. That includes time to eat and sleep, but it's still a long time. It's about 25,000 miles all the way around Earth. That's about 8 times as far as driving across the United States. If you could drive around the Earth, it would take you 60 days. That's 2 months. The moon is about 240,000 miles from Earth. That is nearly as much as 10 trips all the way around Earth. If you could drive there, it would take 550 days to do it. That's about a year and a half driving every day. Once you got there, you'd find the moon was smaller than Earth. It's only about 7,000 miles around. You could drive around the moon in only 15 days. Remember, it would take you 60 days to drive around the Earth. The distance to the sun is 93 million miles. That's almost 400 times as far from Earth as the moon is. It would take nearly 600 years to drive to the moon. Wow, that's a really long time. As long as you didn't take any days off, you'd have to drive straight for 600 years. Maybe the car wouldn't last that long. How about the driver? That's a long drive. Okay, great. Good. I see I have some questions while I was reading. Let's see. From Michael, no, I haven't gone to space. I just have I've studied about it, and I like to look at pictures. I wish I could go to space, but it's probably not. Since I'm a teacher, I probably won't end up going to space. And Alette says, why does the moon look so close? I don't know. I mean, it's a lot closer to us than the sun. And it's actually not that close, but I do understand sometimes the moon looks like big enough that you could reach out and touch it. And Sophia, what page we're on? We are on page 51. And Rebecca asked, are there more planets other than the ones in the solar system? Yes, there are many, many planets out there. There's a lot of things out there, lots of stars and galaxies and other planets and moons. And but what we're going to talk about is just the ones within our own solar system. But there are a lot of planets and moons and stars and suns out there. And Brittany asks, if you put a plant on the moon, will it grow? I don't think so. I'm pretty sure it wouldn't, because where the sun shines on the moon, it gets really, really hot. And where it doesn't, it gets really, really cold. And if you have plants at home, you know you got to kind of keep them at an even temperature and take good care of them. And I think it would be too hard to do that on the moon. Also, there's no air, and plants need air to grow. So that's it. How close is the moon to the sun? What a great question, Brittany. Let's look. I think the way we can figure that out is a little bit of math. So let me just look in my book. So the moon is 240,000 miles from Earth. So I'm going to write that down. And then the distance from the Earth to the sun is 93 million miles. That's a lot. Some math I'm not quite sure how to solve, but my technical support person in the back of my room is busy doing that math right there. And as soon as he figures it out, I'll tell you. It's less than 93 million miles. How about that? That's probably not a super exact answer. Okay, so it's 92,760,000 miles. Great. Good. and the other planets or things. And Milo, you're right. Scientists have discovered maybe a planet 9 in the solar system. They're always discovering and exploring to see what's out there. And Sophia asks, is there more than one moon? Earth only has one moon, but if you, after this, if you look at pictures of other planets have moons themselves. And some of them have one moon, some of them have 2 moons. I think some of them even have 6 or 7 moons or even 9 moons. So if you're interested after this, you could take a look and look at some of those pictures because it's really cool to see when we're used to only seeing one moon. And Tito, you're right. The amount of days it takes to drive around the moon is 1/4 of the amount of days it takes to drive around the Earth. Okay, great, good. Thank you so much for those questions. You guys are thinking of all kinds of amazing things that I didn't even think about. So I'm glad I've been able to answer some of them. Okay, good. So the next thing I'm gonna have you guys do is an activity. So I am going to have you pretend that you could move Earth inside the center of the sun with the moon still going around the Earth. I want you to draw me a picture that shows that the sun is so big that the moon could still be inside the sun. It would be about halfway out to the edge of the sun as it moves around the Earth. So I'm going to put, so I know, I'm going to put up my email address. So when you guys have drawn your picture, your parents could send me the picture that you made because I would love to see it. You can also send me if you have any questions as well. So I'm going to put my email address there. Email address is geographywithrobin@delphian.org. So just to remind you, you're going to draw a picture of the sun, and then you're going to draw a picture of what it would be like if the Earth and the moon were inside the sun. And you want to show that the sun is so big that the Earth and the moon can still fit inside it. Yes, Sophia, I know maybe what I was saying wasn't clear, so I'm going to try to draw it as well. So if I drew the sun, sorry, it's kind of hard, guys, to draw on the whiteboard, but let's, also not a circle sun, but let's pretend it is a circle sun. This could be a solar flare right there. So if this is my sun, then I'm going to say here is my Earth, right? Which is too big for how big the Earth is in relationship to the sun, but you kind of get the idea, right? The Earth would be a dot, and then the moon would be an even smaller dot. So what we're trying to do is just kind of show the differences of size of the sun and the moon. Show the sun was more clear. Here, we're gonna try, I'm gonna try to draw this again. Clear my drawings. Okay, so here, here is my sun. Here, I have someone who's a better drawer than me bringing it. Okay, so there's my sun. Good. And here that dot were even smaller, would be the Earth. And then right around here would be the orbit of the moon. Hopefully that makes it more clear to everybody. Okay, good. Okay, great. So now, someone asked, can the sun burn the earth? I mean, we get rays from the sun, which can cause sunburn, but the earth is not in danger of being burnt by the sun. Okay, great. So now we are going to do the next thing. We are going to read from chapter 6. It's called How Earth Turns, up to the heading called Earth is Tilted. And Molly, you're welcome. Okay, good. So I'm just going to share the next thing that we're going to read. And there are a couple of other activities in this book that I'm going to send you information about after the webinar so that you can do them at home. You could say that Earth is like a top spinning in place. When a top is spinning, you could imagine that there is a line the top is spinning around, like this. The line would go right straight down through the center of the top. Even if the top started to tip over, there would still be a line that was spinning around. The line would be tipped too, like this. A line straight through the center of an object that the object can turn on is called an axis. The line can be real or imaginary. The Earth has an axis too, but you can't see it. Earth spins, rotates on its axis. Okay, great. Most globes are made so they can show how Earth rotates. They often have a thin metal bar that goes down through the center of the globe and holds it in place. The globe can spin on the bar. So you could call the bar the axis if you wanted to, but really it just shows where the axis is. The North Pole and the South Pole. There are names for the places where the axis comes out of the top, out of the Earth at the top and at the bottom. They are called the North Pole and the South Pole. Okay, good. I saw there was a couple of questions that I just wanted to answer. We're almost out of time, so I just wanted to answer a couple of questions. Max had a question on how to send the drawing to me, so I'm going to put up my email address again. My email that you can email me at is geographywithrobin@delphian.org. So I look forward to seeing all of your guys' drawings, and thank you very much for joining me. And you can always let me know if you have any questions, and I hope you learned something and found that it was useful. Okay, have a good afternoon.